Hello everyone. Today we are going to see the initializer list. So what is an initializer list? It was introduced in C++11 and it is a clean and safe and uniform way of initialization. So what exactly does it mean? It allows the initialization of containers or user-defined classes with a list of values inside the curly braces. So that's what the actual meaning of initializer is. So you must have used STL containers like vector and map, and you must have initialized them. So they are heavily used in those initialization. Let us take an example of a vector and let us try to initialize it. So we'll come to the code. I'll create a file initial.cpp. Inside this, hash include iostream using namespace std. Now I'll just create int main, and inside int main like initialize a vector, say vector of int v equals to 1 comma 2 comma 3. So what I can do is first of all let us include the vector library. Right. Now you must have seen or used this kind of initialization in the curly braces. So internally it is actually using the initializer list. So if I'll go to the class for vector and I'll search for the instructor, which is vector initializer list. So you can see there's a constructor which takes the initializer list as an argument. And this initializer list allows you to have certain properties, which is like traversing onto the elements. And we can like discuss these properties with the code itself. But before going to the properties, let us first see the use cases. The first thing that that you have seen is it is used in vector or SCL libraries to initialize. But how is it useful to us in the user-defined classes? So let us take an example of a shopping cart. Say I'll create a class shopping cart. Now inside the shopping cart, say if a visitor visits a shopping mall and there are 10 items in front of him, and those 10 items are numbered from 1 to 10, he can select any item. So I'll just create a vector of int which is items. So these items are the items which are selected by the user or the visitor. So in the public section, I would also take a constructor shopping cart, and inside the constructor, what kind of parameter you would be passing. First of all, the user can select any number of items. So you might think that you can pass a vector over here. So I can create a vector of int, say v, and then I can perform some tasks. Say we are just going to log out using vector. Right. Now, if I want to initialize this, then how can I do this? Say I can have a shopping cart, and inside the constructor, I have to pass a vector. So what I can do is I can create a vector of int, say selected items, and I can pass this selected items inside my constructor. I could have done this. Or what I can also do is I can just pass in empty list. This will also work. So if I try to run it, g++ initial.cpp -o-n, and it compiled successfully. And if we run it, the constructor is called correctly. But the point is that you're passing an empty list over here, right? So it means the user has not selected any item and you're still passing an empty list over here. Whereas if you're creating a vector separately, even then you have to initialize it, and you're not going to push back any of the items till you have to pass the selected item over here. right? Now, if I would say that there is a better way to do this is by using the initializer list. Like instead of taking it as a vector, what I would do is shopping cart, and I would say, let us take the initializer list as an argument. Initializer list, and it will be of type int in our case, say list. Let us keep the name same, list. Now I'll just log out something that using initializer list. So spelling might be wrong. Right. So with this, the initializer list can be used. Now, if I would like to create an object or call the constructor, then I can straight away say shopping cart, and use the curly braces for the initialization, and that's it. Now, if I'll try to run this, let's compile this first. So we have redeclaration. So let us keep the name different. Let us name this 1 and let us name this 2. So now if I'll compile it, it compiled successfully. If I'll run this, then you can see both the constructors are getting called, and it is so easy that you can just straight away pass the empty list. Say if you have 10 items or any number of items that you want to add into the vector. So you can just add it over here and it will work absolutely fine. Right. But it still works. Now, this is the place where it is much useful and it is much more readable as well. Now, what are other points uh, that are upper hand over the normal constructor above the initializer list? So the first thing is that the normal constructors that we use, they do the narrowing conversions internally. So this is not there in the initializer list. So let us say if we have a constructor shopping cart, let us define it below. Say we have a shopping cart, and inside the shopping cart, I'll have int count. It is the count of items that the user has chosen. So see out, say count items selected. And now if I'll try to initialize this with this constructor, then you can straight away say shopping cart, cart 3, and you can pass say 2 elements are selected or 2 items are selected. Now, with this example only, let us say if we have this 2 changed to some float value, say 2.5, will this work? So the point is, yes, it will work because the narrowing conversion will convert 2.5 to 2. So now if I'll compile it, it compiles successfully and 2 items are selected. So you can see the narrowing conversion works implicitly over here. So this can be avoided by using the initializer list. Instead of this, if I do 2 over here, it will still work with the initializer list because we have the initializer list over here. If I will pass 2.5 over here, it will give me an error because the implicit conversion or the narrowing conversion is not available with the initializer list. So the point here is that the possibility of doing the errors is very less if you're using the initializer list. It has some advantages. Now, apart from this, you must also remember that if you have multiple constructors in your class, then in that case, the initializer list is the most preferred constructor. Let us take another example. Let us say shopping cart, and you would pass over here, say one int count, and let us take another argument as int amount. Right? We log out something that count items, and we'll just print out the amount. Now if I'll try to take in, so now in this case, if I'll try to call the constructor, let us revert this back to 2. If I'll call the constructor shopping cart, and I'll take one count as 2 and the amount as say 100, then the constructor can be called correctly. But what happens if I'm going to use the curly braces, 2 comma 100? So in this example, you would see that this in the first case, it will call the constructor, the correct constructor, because we are using the curly braces. We are not using the curly braces. But in the second example, we're using the curly braces. So in that case, it will call the initializer list. So if I'll try to compile this now, let us also put return 0. If I'll compile it now, compile successfully, and if I'll just execute this, so you can see the constructor are called correctly, and the second one was initialized using the initializer list. So there is one more point, that it creates an ambiguity between the constructors as well. In case you're using the curly parenthesis or the curly braces, then you can also call the normal constructor as well. Say if I'll just comment out the initializer list constructor over here. In the previous example, we saw that this curly braces was going to call the initializer list, right? Let us also comment this out for now, because we are passing more than 2 arguments. So over here, you would see that we are passing the 2 inputs, which is count and the amount, in 2 examples. And one is not using the curly braces, and the second is using the curly braces. So in both the cases, what will happen is they both will be calling the same constructor, which is this one, right? So if I'll initialize this, if I'll compile this and try to execute this, so they both call the same constructor. So you can see that using the curly braces, you can call the normal constructor as well. But the point to remember here is, if you have the initializer list constructor, then the priority is always given to the initializer list constructor, even though you have the same signature constructor available in your class. So in that case, it can create certain amount of ambiguity, that if a developer is going through the class, then you would find this constructor as relevant to this part, but still it is not getting called, because this call goes to the initializer list. Now, this was all about the usage of the initializer list. Now, let us also see how what all properties does the initializer list has. So what I'll do is I'll just comment these out. Let us also comment this. Now, the point of using the initializer list is, first of all, that the elements are constant elements. They're not exactly constant elements, but the references that you get from the initializer list, they are all constant. So you cannot change the values. So if I'm going to say shopping cart, cart 1, or say cart 4, and inside this, I'm going to initialize using the initializer list 1, 2, 3, 4. Now, I'm going to use the initializer list constructor that we have already seen. But what if I do list of 0 equals to 1? So it does not allow me to change it. So you can see we get an error, because the references which are given by the initializer list, they are all constants. So let us see the class of the initializer list. So here you can see we have the reference and the const reference. They are all constant. Even the iterators are constant. So you cannot change the values. And the part about the initializing of the initializer list is when you write initializer list in the constructor or anywhere, and when it gets initialized, the compiler gives a hidden memory to this list, and it gives the constant iterator and references. It does not have anything to do with the rest of the memory. You cannot change the any value on that memory location because it is hidden to the initializer list. You just have the reference and the size. So you can get the size over here. In the class, you can see we have the length, we have the array iterator. So you can get the size and iterate through the array, but you cannot change any value. That is one thing. So in interviews, you can be asked that how can you like design an initializer list? So you don't have to ideally go and design like creating constant references and constant iterators. You can do an alternate way as well. So what I'll do is say initial say design.cpp hash include iostream using namespace std. Now, the first thing that you would think while designing the initializer list is that it can take any kind of data type. So we should use the template class, right? Template, and we can say class T. Now I'm going to create a class initializer list, and in the initializer list, I will just take the constant T reference pointer to an array and the size say as said. So with these two as well, you can design the class. So now you can see we have the constant pointer to the array and we have the size of the array. And apart from this, you can have certain constructors. So in the public section, you can have like initializer list, and initializer list you can find with default argument as null pointer and the size as 0. You could have done this. Also, you can take initializer list and you can pass a constant t array, comma, say size t, let us name s, and we'll again initialize our array and the size as said s. Apart from this, you can have certain getters and setters plus the begin and end functions. So you can have like e pointer begin, and you can just return the array over here. So this will return with the beginning of the array, and in the same way, the end can be used to return the array plus we can say size. If we do the array plus size, it will be at the last element of the array. So with this, you can have the begin and end function. Apart from this, you can add some getters and setters as well as per the requirement. So in this way, you can design the initializer list class if it is asked in the interviews. Now, apart from this, like what we saw in the previous example, we could have used, so this is not going to work. So I'll just comment this out. So we can initialize normal classes with the brace initialization, and this will also help in like reducing the errors. Plus there is one problem which is called waxing parse problem. Say right now I don't have a default constructor over here, right? If anyhow I call shopping cart, say cart 5, and I leave it blank, even though it is not showing any error, but we do not have any default constructor over here. Now if I'll try to compile this in C++, say in, so you can see there's an error, which is empty parenthesis word disambiguated as function declaration. So right now you're trying to create an object, but this is referenced as a function declaration, which is called waxing parse problem. So this can be reduced if you use the initializer list or the brace initialization. Now, if you try to initialize this with brace initialization, you will not get this error now. So that is one more part in using the initializer list. So we can discuss one more thing over here is the constructor with an empty argument list. So the point here is, say if I'll create a constructor which is shopping cart, which takes void, and if I'll just see out, say empty arg instructor handle. Now, if I try to call it as a default constructor, we try to compile it and see what do we get. So we get an error that we do not have a default constructor as of now, even though we have passed void over here. But if I try to change this with curly braces, and if I compile it now, it compiles successfully. So this is the difference when we use the empty argument list. So that is one more point added to the initializer list. So that's all about the this topic initializer list as of now. And if you have any doubts, you can ask in the comment section. I have tried to show most of the use cases and examples and all the designs plus the classes itself. So we'll end up this video here. Thank you.